Hello, welcome to this in-depth walkthrough of our Knime Workflow. And in this video, we'll take you through a complete end-to-end process of optimizing the number of topics for LDA. And our primary goal is to determine the optimal number of topics that best represents our data sets. And we will show how this workflow is applied to these two different data sets, one covering the journal article and another focused on political contents. And we'll highlight key differences between the workflows and for that data set and demonstrate how to interpret the results. By the end of this video, you will understand how to build an efficient topic modeling and how to identify the right numbers of topics for your data set. Let's get started.
Hello, I am Vikram. So from here, I'll continue. So we can see on the screen that this is the entire main workflow, starting with the CSV reader. So I'll explain you step by step of and functionality of each individual node. So let's start with the CSV reader. We start by reading CSV file containing articles, data, including titles and descriptions from the local directory. And how we import it here is by clicking on the setting. Uh, See here we can here read from local file system and import the file from that directly, and we can easily get the access to that file and import it to the CSV reader. Now next step is string to document reader node. This node converts the next columns text columns into a document format that can be processed by text processing node in this overall workflow. The next step is pre-processing. It's a component. In this component, if you open it, we will have multiple nodes. So let's see one by one. The first one is the input component. Input component is the connection of initial stage, like custom pre-processing component. It receives document data from the main workflow and pass it through multiple pre-processing steps to clean the and prepare the text that we received or that we imported. And next node is markup tag filter. This node improves and removes unnecessary HTML tags and markups from the document. This is especially useful when we work with scrapped web contents or structured documents containing hidden formatting tags. So this is how, if you see here, if you open the content in it with the document viewer, it looks somewhat like this. Here we can see it is a structured and scattered, segregated way. Page one, page two with individual topics. So let's go to the next. Stanford tagger. Stanford tagger, it's a part of speech tagger, identifies and labels each word in text based on its grammatical role, especially like noun, verbs, adjectives, and all these parameters. This information help us filter and prioritize certain type of words later in the process that we'll see going ahead. So next step is the Stanford Lamatizer. As we already discussed in the class, as sir explained to us, the Lamatizer reduces words to their base or direct dictionary form. Like example, as taught by sir, running becomes run, better becomes good, to ensure that we treat different form of same words as one. So next will be like punctuation erasers. Basically, we it is a generic thing like we all know. It removes the punctuation marks and they don't contribute meaningful information in most of the text analytics. So it removes all the unwanted punctuation marks. If you see here in this result using document viewer, it may take some time. Okay, so here we can see here there are no punctuation marks. All the punctuation marks are removed and everything is like highlighted by color coding. Number filter. Uh, It filter out numerical values that may not appear in the text, such as dates, quantities, IDs, which are not typically useful for text modeling. And n-chaser filter. So here it is also one of the important. It removes short words which fewer than a specific number of characters. For example, we have seen in the class words with one or two letters like and. These words are often stop words or less informative words. So it will like compromise with those things and removes them. or filter rate. Last to one, stop word filter. So this is that this node removes commonly used words like is, at, the, which do not carry any significant meaning for our analysis. And last one is like case converter. Here the case converter converts all the words to lower case, ensures consistency and prevent duplicate caused by different capitalization of the same words. For example, we'll see what it has done. Go to this Word document viewer and open the results containing in this. We can see none of the words are in capitalized format. Everything is in case like small letters. Go to next sheet, go to next sheet. You can see all are in small letter format, lowercase format. So this is how the pre-processing part. But let's go back to our topic modeling main workflow. Uh, Here we have rule-based row filter. What it does, like this filter out the documents based on the rule, especially documents with fewer than 10 terms or remove to maintain data quality and focus on meaningful content in the document. And column filter. Let's see. Finally, the column filter keeps only the relevant columns needed for a further analysis, such as pre-processed documents and meta nodes. So if you see here, go to the settings, we can clearly see the things that are needed included is only document content is included, and excluded title, text, and number of the terms has been excluded from the documents. We can easily consider which one to add, which one to remove. So so here in this process, we quickly walk through over the pre-processing part of the main workflow. If we clean and filter the text date and data and prepared it for the next step in our analysis. In the next section, we will show how this data is used for the topic modeling.
Progress. So I will explain the next part of the workflow from table creator. So here in the table creator, as we can see, this node creates a range of topic numbers from 2 to 40. This value represent the different number of topics that we want to test in our LDA model. Then topic extractor, how does it work? Like it will assign topics like topic 0, topic 1, and there will be some words with respect to those topics. So correlated words will be there for each topic. Then topic model goodness of fit will evaluate the correctness of the assignment of these words to the each topic. Then we have a math formula load. This node dynamically tracks each iterations and labels the output with corresponding number of topics, ensuring that we are easily able to compare the results. So here, each dataset variation retains the topic number for comparison through two different nodes that has shown parallelly. Now, moving to the loop end and column filter. So what it does the loop end node collects all the results from each iteration, which are then filtered to retain only the relevant columns for the visualization. Here are the configurations. Then similar works are related to the column filter and column renamer. So this will improve the visualization part. So column filter will keep only required part for the visualization, and column renamer will be basically corresponding to the labels in the visualization. Now coming to the line plot. So here is the line plot. As the number of topics increases, the chi-square value also decreases, but more number of topics will not be favorable for any analysis. So what we are doing like we can use the elbow method here. So approximately like 15 will be the number of topics, optimal number of topics that we can decide from this elbow method. Because after this, the marginal decrease in the chi-square value will be much low. And the line plot visualization, the chi-square value for each number of topics, helping us to identify the optimal value. For articles data set, the chi-square value will be, as I said, it will be stable around 10 to 15. And chi-square value in the line plot represent how well the extracted topics capture the variability in the data set. Thank you.
Uh, Hi everyone. Now I will discuss about the second part of the workflow, which talks about the political, purpose. So let me go through each step. So first we have the CSV reader, which will, kind of read the data from the file, and then we have strings to document converter, which will kind of, convert each of the row of the Excel file into of the CSV file into the document format, which is kind of needed for us. Then we have the column filter, which removes text data and metadata, so already added to the column type. Then we have pre-processing node, which is customized for having this political purpose data. So here, what essentially we are doing is if we open this, yeah. So here we are having different, kind of filters like stop word filter, punctuation eraser, number filter, case converter. So this like punctuation eraser is removing if there are any punctuation marks, commas, etc. from the text. Then case converter is kind of having using the lowercase, converting all the uppercase into the lowercase, and like that. Here we are also having unfrequent words. So again, if you open this, it is having the bag of words creator, then the column filter, the row filter, which is kind of exploding words which are kind of occurring less than 5 times, as it will not make any sense, or it will not have any topic related to that. So all these things are explained here. If we go to the main workflow, then we have the row sampling node. So since the political data set is larger compared to the first one, we randomly sample 500 rows to reduce the computational time while retaining the entire representative data set. So if I show you this, so here you can see that it is having the 500 as the absolute value, and it is drawing it randomly. Then next we have topic extractor, which is parallel LDA, which is similar to the earlier dataset, earlier workflow. So it will, what it will do is it will apply LDA to the dataset. It will extract key topics from the political text. Then the goodness of model fit is there. Here we evaluate the performance of model using a chi-square, similar to the first workflow. And then next we have math formula. So if you see here, if you go to topic extractor and if you connect it to the table view, here you can see that it has given the topic ID and given the term particular related to each topic ID and the weight. So more the weight means more important the topic is in the entire uh, document. So if you go see the goodness of it, here you can see it is giving the chi-square and chi-square normalized value, so which is kind of indication of relative to the entire uh, number of documents present in the data set. Here in the math formula, again, it has introduced the topic model. So you see the formula is like topic model. So here, like as we have initialized in the earlier table creator, we have number of things to be, number of data points which we wanted the model to, search the topics for in the entire purpose. So here you can see that it has given 40 as the topic model. Here and see. So it has calculated for 40. Similarly, it will do for 2, 5, 10, and for everything. So it has added this topic model column extra compared to earlier for our better understanding. In the loop end, it will collect all the optimization data and it will also give the iteration number compared to the earlier one. Now we have the column filter. So the column filter will remove all the rows and it will only all the columns and it will have only the chi-square normalized value, topic model, and the iteration number. Now we have renamed the chi-square normalized value to normal chi-square only in this step. And finally we have the line plot. So in the line plot, here it will give us a pictorial representation of the line. So here you can see that uh, around the value of 20, the kind of curve is going to, kind of getting flat, which means that around 20, it is the value uh, which is having kind of minimal change in chi-square after that. So this is our most optimized value as we have seen from the model. For earlier data set, it was around 10, 15. Now for here it is 20.
To wrap things up, so let's summarize what we have learned. In this workflow, we optimize the number of topics for two different data sets using LDA and evaluated the goodness of fit using the chi-square value. And the articles data set showed an optimal number of topics around 10, while the political data set stabilized around 20 topics. This approach ensures our topic modeling is accurate and relevant to the content of each dataset. And by leveraging Knime's powerful nodes and looping structure, we created an automated scalable solution for topic model optimization. And we have plotted a chi-square line plot in which we can see the chi-square values. And that was our model. Thank you for watching.